In this lesson, we'll explore specific quantifiers in regular expressions. These quantifiers use curly braces to give you precise control over how many times a character or group should appear in your pattern. Let's dive in and understand how to use them effectively. Let's start with the basic syntax of specific quantifiers. The first syntax is ON. It matches exactly in occurrences of the preceding character or group. For example, to will match AA, but not A or AAA. The second syntax is AN. This matches N or more occurrences. So A2 will match AA, AAA, AAAA, and so on, but not A. Now let's look at the range syntax, represented as ANM. This matches between N and M occurrences inclusive. For example, A2 for will match AA, AAA, or AAAA, but not A or AAAA. The N represents the minimum number of occurrences, and M represents the maximum number of occurrences that will be matched. Here's an example of using the exact count quantifier. The regular expression \D3 matches exactly 3 digits. The \D represents any digit, and 3 specifies that we want exactly 3 of them. This pattern will match 1, 2, 3, 4, 5, 6, and 7, 8, 9. It won't match 1, 2, because that only has 2 digits, or 1, 2, 3, 4, because that has 4 digits. Let's look at an example of using the minimum count quantifier. The regular expression, A2, matches 2 or more lowercase letters. The A character set represents any lowercase letter, and 2 specifies that we want 2 or more of them. This pattern will match AB, CAT, and HELLO. It requires at least 2 lowercase letters to be present to be considered a match. Here's an example of using the range count quantifier. The regular expression \W2 for matches between 2 and 4 word characters. The \W represents any word character which includes letters, numbers, and underscores, and 2 for specifies that we want between 2 and 4 of them. This pattern will match AB, CAT, and WORD. It will not match A or WORDS. Now let's see a practical code example of using specific quantifiers for phone number validation. We start by importing the Re module, which is Python's built-in regular expression library. The phone pattern is defined as R \D3 \D3 4. This pattern checks for a phone number in the format XXX, XXXXX, where X is a digit. We then define a phone number string 555 123 4567. The code then uses re.match to check if the phone number matches the defined pattern. If it does, it prints valid phone number. Here are the key takeaways from this lesson. First, N gives you precise repetition control by matching exactly in occurrences. Second, NM provides flexible range matching by allowing you to specify a minimum and maximum number of occurrences to match. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.